All right, we're talking about measuring matter, chapter 1.6. This is about accuracy and precision. All right, so measuring with accuracy means that you are taking measurements close to the actual or true value. Okay, so you can think about it like this. If you have a football goal, and let's say you want to get that football right between the goalposts. All right, let's say that that's like the true value. That's right where you want it to be. That's correct. Okay, that is accuracy. All right. But you can also have precision, which means that you are taking measurements that are similar in value, but that does not have to be the actual value. Therefore, you can be precise, but not accurate. For example, if you throw that football twice and it doesn't go in the goal, but it goes within a few inches of each other each time, that is precision. All right, so it's best to measure with both accuracy and precision in science, okay? So if you have both, then it's true. So that's reliable, right? And that's replicatable. So replication. And as you see, you can accomplish accuracy and precision by making several measurements, okay? So then you can be more sure, all right? Less deviation from what you think the true value is. So that's about replication. You can have more accuracy and precision by doing replication. That's why we do experiments more than once. We do them at least 3 times, and you probably really want to do more than that, actually. Okay, units and dosing. In a hospital or in a clinic, healthcare professionals are using the metric system, or SI. But they also must be familiar, those professionals in a hospital or a doctor's office, with the US system of measurement. The way you refer to these measurements in your kitchen, right? These are how the patients are referring. So that's why I was saying in the last video that it's good to be able to relay one to the other, to be able to understand those conversions, even though they're a little more different than just converting within the metric system. But you have this table here that shows how do you convert from the metric system to the US customary equivalent, and you can make a conversion factor with this and do some dimensional analysis. So get to know this table. All right, so you can see where you have mass, in mass we're measuring in grams, but the US customary unit is pounds. So how many pounds go in a kilogram? 2.205 pounds. Okay, so you're going to use that conversion factor sometimes. Okay, and so on and so forth. You see that 1 mile is about equal to 1.6 kilometers. Okay. So whenever you're going to be looking at lab reports, because a lot of the people in this course are in allied health and going to be nurses, you're going to be given a lab report that you're going to assist patients in viewing. And so patients are given results with these normal values, and they're given a range. And if something is not in that range, it's high or it's low, it's going to be highlighted. Okay, if it's high or low, it's going to be highlighted. All right, so just keep that in mind. These are things that you're going to be doing on a daily basis. Values that are listed greater than a 1, okay, they're listed greater than 1, and this makes the units on the numbers vary widely. So usually you're talking in terms of the metric system, okay? Often you're going to hear about deciliters. All right. I don't know why that's not written right there in your notes, but a deciliter is equal to, right? How many deciliters are in a liter? It's a tenth. Okay. or 100 mils. You're going to hear a lot in those reports about millimoles. That's the equivalent to 1,000th of a mole. All right. And the mole is the unit used to count particles in matter. So write this one on your flashcard. A mole, that's the unit to count the particles in matter. Okay. So we talked about atoms before. Now we're talking about a unit for counting particles in matter. All right. So similar to a mole, they use milliequivalents for electrolytes. All right. Electrolytes are really important in conveying electrical impulses or electric signals in your body. So in the US, we talk about weight in pounds, right? Remember, that's the unit. You don't just say I weigh 100, you say I weigh 100 pounds. But pharmaceuticals often are dispensed by body weight in kilograms. So that means you're going to have to do a lot of converting, right? Okay. Keep that in mind, and we're going to work a lot of problems like that. All right. So when you do this, when you get these problems, you want to decide, determine the units for the final answer. So what am I looking for? What do I need? Okay. Then what do I have? What do I need? What do I have? Determine the conversion factors. Okay. What conversion factors do I need to get there? And then set up the equation, plug it in, and work it out. So another way that another common measurement of matter that you're going to be dealing with as a nurse are drop units. So, you'll have a patient in the hospital who might need IV delivery of potassium, for example. So this is often measured in drops per milliliter, abbreviated GTT/ml. Well, why is it not, DR per ml? But that's because this abbreviation GTT is short for the Latin gutta, and I may be saying that wrong or incorrectly, but that means a drop. Okay, so in English, the drop factor is used to determine the drip rates. Okay, so this is what you're using whenever you need a prescribed volume of medication in a certain specific or period of time. So drop factors are going to vary with the diameter of the IV tubing. So they're going to be dependent on that. All right. So basically the size of the drop is determined by the diameter of the IV tubing. So that's going to have an effect on the drop factor, okay? Or how much medicine is going to be dripping at a given period, okay? The drip rate. So something else that you're going to see a lot of are percents in health. The percent active ingredient, okay, that's something that you're going to see a lot. You can see that on the back of a box of Benadryl or Excedrin, because the actual active ingredient has this high potency to increase the size of the pill to be something that makes sense. They're going to use different binders, and that way you're going to have to express what percentage of that tablet is actually the active ingredient. Okay, so like acetaminophen within a Tylenol tablet. So the percent of adult dose is something that you're going to have to especially be concerned with pediatrics. Children are smaller than adults, so they're given a percent of the dose required for the adult. Okay, in nutrition labeling, so this is what you see on your box of granola bars, telling you the amount of carbohydrate, protein, and fat, as well as the daily percent value. Okay, showing the contribution of that serving to your daily dietary requirement. Remember those macro and micronutrients, okay? And also you're going to see how many calories are there. So you remember the capital C. Again, remember, that's 1,000 calories with the lowercase c. Okay, so this is your review for Chapter 1 study guide. We'll talk about this a little bit in class before you have the test, or just to sum everything up, but you can use this as a checklist. They have each section of the chapter. Make sure you remember what was gone over in those chapters. You can talk about it out loud, teach it to yourself, your younger sibling, someone else. So it's basically a checklist that's already available for you right here. So now we're going to start solving some problems, and we're going to do this in class. So make sure you bring your calculator this Tuesday. All right, so let me pull up these problems for you. All right, we are on chapter 1.6. Okay, so we're going to work the odd problems, right? Identify the following as good accuracy, good precision, both, or neither. A, tossing 3 horseshoes, none of which lands on the center pole. So you have your horseshoe pole here, you have your horseshoe here. Let's see, the horseshoes are scattered on either side. Okay, so they're not next to each other. So they're all over the place. So is this accurate, precise, both, or neither? Well, that's neither, right? That's neither. So let's see maybe if there are some other examples, right? Because they're not all in the same spot. They're not precise. They're not around your target, so that's not accurate. So that's neither. Okay. So let me erase this. Okay. Tossing 3 horseshoes around all ringers on the center pole. Okay, so that is what? So all of them are on the center pole. So all, you see all, okay, that indicates that's precise, right? Okay, and they are on the center pole. So that's where you wanted them to be. That's what? That's both accurate and precise. Now, tossing 3 horseshoes and all 3 land 3 feet in front of the center pole. Well, they didn't land on the center pole. That's not accurate. But look, all 3 land 3 feet in front. So you can say that that was good precision. All right. So that makes good sense. All right. And we'll do the other example in class. 1.53. A low dose of aspirin is often recommended for patients who are at risk for coronary artery disease. Low dose aspirin contains 81 milligrams of acetylsalicylic acid per tablet. How many grams of acetylsalicylic acid will a patient take over the course of 5 years if they take 1 aspirin tablet daily? Okay, so let's start working this out. This is our favorite. These are our conversions. So what are we going to do? We know, let's see, what do we want in the end? It says how many grams. So we know that at the end of it all, we want our answer to be in grams. So we start, so that's what do we need. So the next question is, what do we have? Okay, we know, so we're going to want how many grams for that patient. So we know that they are taking 1 tablet per day, right? So let's see, a low dose aspirin. All right, this per tablet. So let's just start off saying we're going to want to know how many grams that they're taking daily, but we know that they're taking 1 tablet a day. Okay, 1 tablet, 1 day. All right, so conversion factors. So let's see what we have. All right, we have milligrams, and we're going to need to be going to grams. So what conversion factors do we need? Years, we have days. So we're going to need to get over to years. We have to keep that in mind. let's go ahead and get started. So that's what we have. So we have 1 tablet a day and we need to get to grams. All right. So eventually we're going to need to cancel out days, or we're going to need to figure out for how many years. So we're going to need to work out the time, but let's go ahead with the tablet first. Okay. So how much is in 1 tablet? Do we have that information? We do. We have 81, because we know if we're going to need to figure out how many grams per day, we need to start with the milligrams that the low dose aspirin contains. Okay. So can we write that in a way that cancels out already tablets? Yes. We can write 1 tablet there on the denominator, and the numerator 81 milligrams. Okay. So we're going to be multiplying that out. All right, so we're in milligrams, but we need grams eventually. So let's use that conversion factor. Which one do you need? You're going to need, okay, so milligrams on the bottom, right? You're going to need to get to grams. How many milligrams in a gram? 1,000. All right. So you're going to multiply again by another conversion factor, because we've canceled out tablets. We've canceled out milligrams. So we got grams per day, but we need to know for years, right? So let's make it simple. Go with 1 year, which is how many days? So we have still days over here, 365 days. Okay. So, and then we're going to multiply that by 5 in the end. 5 what? Years. So years cancel out. You do your multiplication and you get 150 grams. Okay, that's how many grams that patient is going to take over the course of 5 years. Okay, so that's how much low dose aspirin. Now let's move on to the next one. Take your time with these. This is where, you know, people tend to really need to spend some time, slow down, and do extra problems. So 1.55, we have an allied health question. I like these. Give drug X, so it doesn't matter what it is. We're just looking at the numbers here. Give drug X 5 milligrams per kilogram per day in 2 divided doses. The patient weighs 44 pounds. Okay, so this is a child probably, or not necessarily. This is just a person that weighs 44 pounds. How many milligrams should be given per dose per day? Okay, so let's see. We know that the patient is, why you have to take into account, and I told you that you were going to be given pounds often, and doses were going to come, or drugs were going to come in mgs per kigs. That's just my abbreviation of saying that, milligram per kilogram. All right, so here we go. So we have, what do we need at the end? We're going to need how many milligrams, how many mgs per dose for that patient per day. Okay. So we have a patient, we know, so that's a sure thing. That's what we got to start with. This patient is 44 pounds. So 44 pounds, 1 patient. Or you can think of that. So that's the dose per patient. Times what? So we need to convert to kilograms. All right, so that's one of our conversion factors. So how are we going to do this? So first, you need to remember your US customary unit relative to the metric units, right? So 1 kilogram equals how many pounds? 2.205. So you're going to multiply again. And what's your next conversion factor that you're going to use? Okay, so this time you're using, so here you cross off your pounds, and now we have your 5 mg. Okay, so you can do 5 mgs per 1 kg dose. And so if you look, sort of abbreviated here, but basically we're going to cross out kilograms and we're going to multiply out, and we have 5 mgs here, and we're going to get a total of 50 milligrams per dose per patient. If we do the math, you see that it's divided in 2 doses, right? So originally you get something like on your calculator, but if we're looking at significant figures, all right, it's 100 mgs per kgs per patient, and you're giving 2 divided doses. So if you divide 100 by 2, you're getting 50 milligrams dose per patient. Okay, so they'll be taking that, you know, maybe in the morning and maybe in the evening. Got that? All right. Okay. So 1.57, allied health. A child is prescribed morphine sulfate at 50. A lot of times we write micrograms this way in labs. In the clinic, you'll see it sometimes as mcg per kilogram per dose. The child weighs 85 pounds, and the solution is available as a 5.0 milligram per mil vial. How many mils should be injected? Okay, so what are we looking for? How many milliliters? What do we have? We know that we have an 85-pound child. All right. Let's see. We know that we have an 85-pound child. All right, and we have the solution in a 50 mg per mg vial, and we're going to need to go from pounds to kilograms, right? So we've got several conversions that we're going to need to account for. Okay, so we're going to need to go from pounds to kilograms. We are going to need to go to the micrograms. All right. So you just start to list off the conversions that you're going to need. So we're starting off, who are we working this for? An 85-pound child. There's one of them. Okay. So we're looking for the mg per dose, and that's in a child. Okay. So that's how we're going to balance this out. So we're going to need to find pounds. And so we have 2.205 pounds. We have 1 kilogram. So now we can convert to our metric unit for weight. Let me move this equal sign. We're going to need some space, I think. All right. So now you're going to convert from 1 kilogram. Now we're going to get to micrograms. Okay. So micrograms, how many do we have? We have 50 micrograms. And you can write it this way. Just write it whatever you feel comfortable with. 50 micrograms. And now you're going to need to get from these micrograms, and there's other ways you can work on this, but micrograms to milligrams, because, right, how many mils should be injected, and this is in mgs per mil. So, and we're going to give our answer in the mils per dose. So we need to get over to milligrams. So we have in We're going to go over to milligrams, and we're going to get rid of the micrograms. We have 1,000 micrograms in a milligram. Okay, multiply by, you have 1 mil. So in 1 mil, you're going to have, because you want your answer in mils, right? 5 mgs. Okay, so you cancel out, and you get a total of 1.39 mils per dose per child. Okay, all right, so that's how you work that out. Try to get familiar with that. What do I need? What is it that I'm really looking for at the end? How many mils should be injected? So mils per dose. Okay, and you have to know what you're starting with. Okay, an 85-pound child, because everything is per kilogram. So you start with the mass of that child, get that over into the metric system, and then you can work out the conversions with the amount of mass that you have for those containers of that specific drug. Okay. You definitely don't want to give too much morphine to anybody, especially, you have to be very considerate with everyone, and with a small child, that could be really dangerous. That's why these conversion factors are especially important in understanding these calculations. Make sure you spend a lot of time with it. You're going to have to sit down, do some thinking and some practice. Okay, 1.59. We're getting close to the end. We just have one more after this one, just 1.6. So hang in there with me. 1.59, an applied question. A patient gets 2.0, we'll just say it out loud, keep our scientific units, let me move this down, gets 2.0 liters of fluid over 18 hours through an IV. Okay, so remember we talked about drop factors. The drop factor, you have to think about drip rates. The drop factor is 20 gutta per mil. Calculate the drip rate in drops per minute. Okay, gutta per minute, or drops per minute, if you want to think of it that way. So let's see. Let's think of where we need to get to. We're looking for GTT per minute. Okay. And we know that we have liters over hours. So that's what we have to start with. 2 liters in 18 hours. All right. So you're going to have, what do we need to change over to? We're going to need to change over to GTT, liters to mil, and we need to go from hours to minutes. So you can see, this is how you see which conversion factors you need, how many you're going to need. All right, so let's go over, if we're going to start out this way, we're going to need to convert liters. So if we're going to cross off liters, how many liters, we're getting over to mils. Mils are in a liter. 1,000 mils. Okay, so next we're going to cancel out. You can cancel out mils next, or we can change time over. Okay, because we still need to get rid of hours, right? So how many minutes are going to go into 18 hours? Well, so basically you're going to multiply across, right? So you're going to have 1 hour up here, and you're going to have 60 minutes per hour in that denominator. Okay, so as you're doing this math, think about what it really means. Does it really make sense? Okay, and you multiply that by, so you still have your mils up here. So how many GTT per mil? So you're going to be multiplying that 1,000 by 20 up here, because you're given that. 20 GTT per 1 mil. So in each mil you have that much, so you're multiplying that by 1,000. Okay, you see that? So I think this is probably starting to make more sense to you at this point. And so you're left with GTT, you're left with minutes, and your answer, if you do all this math in your calculator, should be 37. How many sig figs we use? We're given 2. Okay, there you go. That's your answer. Let's do 1.61, and then we're going to take a break. Allied Health, a tablet of Benadryl and antihistamine, so this is to help with allergies oftentimes, has a mass of 0.50 grams, okay? But it would be smaller than that if it was just diphenhydramine, HCl, right? So you know that there are other ingredients in Benadryl, all right? So it contains 25 milligrams of the active ingredient, diphenhydramine, HCl. What percent of the tablet is the active ingredient? So percent, y'all remember what percent is? That is part over whole, okay? Keep that in mind. So we're going from numbers to percent. So remember that this is what you want in your answer. So you write that out. What percent? So to start off with, you know that you have 0.50 grams. All right. So you're going to want to get rid of grams because what? You're going over to milligrams. So you can list out, you know, what you're going over to before you begin. So we need to go over to milligrams. And I think really that's all we're doing right here, because then we're just going to go into percentages. So if you have 1 gram, then you're going to have how many milligrams there? 1,000. And if you multiply that out, you're going to get 500 milligram tablet. Okay, but we're not done. You need your answer in percent, so that's why you need to practice this. So don't just stop right there. The question is what percent? Be careful. I can't stress that anymore. You don't want to make a mistake, and if this is A on the test, you choose this. You need the percent, all right? So we have what? Our part, 25 mgs. So now we have the same unit, so we can do this. Over 500 mgs. You do your division, and then you're going to multiply by 100 and add a little percent sign. You're going to get 5 and keep your significant digits. 5.0% of diphenhydramine HCl and your Benadryl antihistamine tablet. All right, guys, I hope this is helpful for you. We're going to do some more of these in class. I know it's a struggle. Please take some extra time, because on the test, you're going to be, your best friend packet's going to be good for you, and also your knowledge is going to be good. You're going to have to know how to apply this. So don't put it all on the best friend packet. Your best friend is one of your best friend packet is one of your best friends, and you are your other best friend. So you really need to take time, work some of these problems, and make sure you can get the right answer. Okay? So, all right. Thanks for watching the video. See y'all soon.